Hey guys, welcome again to the channel, and continuing with the searching and sorting section, we have a next problem, maximum subarray sum. So yeah, this problem is a very common one. You might have heard it as Cadane's algorithm also. So what is this about? Let's see. So in this problem we are given an array of n integers, and your task is to find the maximum sum of values in a contiguous non-empty subarray. So basically, you know what is a subarray, right? It's a contiguous part of any array. So there's a difference between subsequence and subarray. So subarray should be contiguous, like you can't leave any elements in between, but in subsequence you can skip some of the elements in between. Yeah, so that's about the subarray thing. So now you have to find the maximum sum of the any non-empty subarray. So if this problem would be very simpler if all the elements were positive, so you can just calculate the sum of the whole array and that will be the maximum because every element is positive. But the catch here is elements can also be negative. So in your subarray there will be some elements which will be decreasing the sum of your subarray, but uh, there will be some elements that are positive and bigger that will be leading to the sum being increased. So yeah, that's about it. So let's start how we can approach this. So if you start from the first element itself, -1, so current sum is -1, right? So okay, now you go to the next element, 3. So now you tell me, okay, I'm not telling you guys the approach. You tell me, if you start a new array from here, will it be more profitable for you, or if you continue that previous array, it will be more beneficial to you? Yeah, I think you guessed it right. You have to start a new array from the second element because -1 is of no use to you, right? It will be decreasing our sum, current running sum. So yeah, so we can keep track of the maximum sum till now. So till the 0th index, maximum sum was -1. Now you reach the first index. This element is 3. So you want to start a new subarray from here, right? Because -1 is of no use. So you just discard the previous sum and you start the new subarray and the new current running sum from here. So current sum is 3 and the maximum sum which you are keeping track also is 3, right? So first of all, just you can listen to my approach, then when you will see the code you will find it very simple. So yeah, current sum is 3, maximum sum is 3. Now you reach to this second index. Now your element is -2. Okay, so previous sum is 3, so you are getting some sum, right, from previous. If you start a new subarray from here, it will not be beneficial because it will only result a sum of -2, but you are getting a positive sum from behind, so you should take it definitely. Although your sum will decrease by -2, but already 3 is considered for being an answer, right? Maximum, because we are storing maximum sum at each point, so 3 is already being considered for the answer. So let's continue this subarray. So current sum is 1 because 3 minus 2 is 1. Now we reach this subarray. Now we reach third index, 5. So now you will understand the point why I continued when I got -2. So if I would have just started a new subarray from here, so my answer would be -2, then I would have reached 5. So I'm getting a negative sum from behind. So if I'm getting negative sum from behind, that's not a use for me, so I would have started fresh from here. So in that case my current sum would be 5, but the case which we considered is we included -2. So what that resulted, we got a 1, overall sum of 1 from behind, and we include it in the 5. So the current sum is 6. Now I think you understood, right, why I took -2 in my subarray also, because the overall effect of the -2, it resulted the sum still being positive, that is 1. So yeah, 5 plus 1, 6. So current sum is 6. We considered that for the result. So till now maximum sum is 6. Now we reached here. So 6 plus 3, 9. So yeah, sum is 9. Okay, now we go, now current sum is 9 and maximum answer is also 9. Now we reach this index. So 9 minus 5 is 4. Current sum is 4. Now we reach here, 4 plus 2, 6, and then 6 plus 2, 8. So this whole subarray will sum 8, but the subarray sum till here will be 9. So this is maximum. So yeah, that's enough of talking. Let's see the code. Okay, so yeah, here's the code. You can ignore this comparator function, that's irrelevant. Okay, so or you want me to okay, you can understand why this code only. It's very simple. So you take the input array, you take the input and you start from the first index, okay, and you initialize your current running sum with the first element of the array, that is the 0th index, and the result, that is the maximum sum, also with the first element, and you are starting with the first index, that is the second element, and you are simply traversing till the end. Now if current sum is less than 0, that means from behind, from the previous subarray which was being continued, you are getting a negative sum, so that's of no use, right? So we reset our sum to the current element, and then we increment the uh, s pointer, current pointer, whatever, yeah, and we have resetted the current sum to the current element because we are getting a negative sum from behind, that's of no use, so we just discard that and we continue fresh from beginning, okay. Otherwise, if we are not getting a negative sum from behind, that means we should include it, we should take the current element in the previous subarray only, right? Because previous subarray is giving us some positive overall sum, so we should include this element in the running subarray only. So yeah, we just simply increase the current sum by the current element, and we at after each step we just check for the result, we maximize the result. I hope this is clear, right? This was simpler. Only simple logic is whenever you reach a point, you check if from behind I'm getting a positive sum, that will be beneficial to for me, so I will carry that with me. Otherwise, if from behind at any point I get a negative sum, so I will discard that and I will start fresh from that point, a fresh subarray. And at each index when you reach, you just find the maximum sum, you compare with the current running sum, and yeah, that's about it. Yeah, so that was about this problem. See you in the next one. Till then, keep coding.